Here I have the infamous Makita coffee machine, known for their speed and efficient use of batteries. I actually don't have any Makita batteries. However, I figured I might be able to add an Anderson plug to it and use a 100 amp hour lithium plug. Looking at here, it's the 18 and 12 volt, and I have one Makita battery that's a 12 volt for a heated jacket, and just from probing, looks like this is the negative, that's a positive, and that's some sort of temperature sensor. So by putting a 10k between temperature sensor and ground, it allows this thing to run. On an 18 volt, interestingly, you need the 10k between the sensor and the positive. However, it still draws so much current, I don't have anything to run it. Bench power supply trips at 3.5 amps, and then when I tried this on a large battery, I didn't have anything to get to that, and these melted. So, like the previous owner, if you got the right idea, maybe check that over the fire or the camp stove, and it'll probably heat up way quicker. Otherwise, we'll take it apart, have a look. Looks like first there were 2 screws there, 2 at the top for a battery cover. If it comes off, oh. So, actually it looks like there's screw terminals in there. So, I mean, there's your, are they soldered? Interesting that they've crimped some and then soldered others. But I see interesting things. So all screws are at the bottom. Will it just come off? Yes. Ooh, it is indeed. So what's that? So there's our button, an LED. Top brand, whatever that means. And then, I don't like how, is that some sort of, I hope that, probably not heated, although that said, that's insulated. All of our power comes into this terminal block, and then is going to this main board here by the looks of it, the heatsink. So I know when you put it on 18 volts, it sounds like it's got some sort of boost buck converter. You can kind of hear it on 12 as well. I'll see if I can get that board out. But in theory, we could just undo that, drill a hole in the side, and have some of this 50 amp cable coming out of the machine. Alright, so that main board there is out. We got a button switch there. It's probably, is that temperature sensor? Probably. There's annoyingly quite a fair bit on this board, whereas I guess gotta make it as complicated as possible. Assume that is some sort of boost converter. I'm not going to remove it because I'll probably destroy it, but I want to. Or it's probably a heap of MOSFETs for the heating element. I didn't want to, but I did end up taking it out of that thing. There is a lot of extra solder for current capacity on that. Didn't notice on the heater side there's humongous diodes. I think they do. Oh no, they don't. Okay, so the negatives are terminated together. Your positives are separate. That's your main processor of some type there. It's got a number. I just can't read it. It's too small. Can this zoom in enough? Oh wow. Maybe I will be able to read it. Anyway, so what was I saying? I presume some part of that is voltage regulator to provide that with power. They got some circuitry to read the little temperature sensors. So I thought initially these were terminated together when they came in. However, a closer look, they've actually got these 2 components between them, which are fuses. It still kind of makes me a bit nervous because it means the only mechanical blockage they've got is that slide door that prevents this thing from just 2 batteries together. But I guess it's better than nothing, probably sufficient. By the looks of it, this is just terminated the entire way around to your, no, sorry, this is, so the fuses are jumping to here, and it goes all the way to your positive. This, however, goes up to your little, I presume, transistors under there, where it is then switched out this side to that. And that's probably the high frequency switching you can hear when this thing runs. The only other thing I can see is two, like, I think they're 3 ohms, 0.003, I can't see, resistors, which I assume they're using as current shunts. And maybe that is how, on my power supply, it knows that it's insufficient current. So, yeah, there's a fair bit on it, but nothing super fancy. But now knowing that the two incomes of the power supply are pretty much the same, I'll chuck just 12 volts on it, or maybe 14 volts if an alternator is running, and see if it can just brew on maybe 30 amps. Hardware wise, I don't want to really open it up much further. That is the output of the water. This is some sort of heating element. Then there's some silicon that goes to the top. I don't see a pump or anything, so I don't know how it's getting water out. There's your two heating element bits. That's for a switch, that's for a temperature sensor. So, no pump. Is it just very slow? Not sure. Alright, for test purposes, I've cut down, is it either one of those? Neither one of those. One of these to size. And connected up my wires out there. And then I would have an Anderson, but because I just want to see if it actually runs, I've got two tiny terminals to run at maximum 30 amps off my lithium battery. Alrighty, we're going for the full 30 amps and maybe a car fire while we're at it. It's leaking water everywhere. There's the termination, that's the thermal sensor. Don't even have the right crimp size, so we got 30 amp fuse, grounded. See if it turns on or catches fire. It's on, it's running. Will it make coffee? I do have the thermal camera as well, but we'll probably start a timer. Or a stopwatch even. Is making an incredibly high noise, high pitched noise. There's the thermal camera. What's on fire? Stuff is getting hot. That fuse is getting hot. Fuse is sitting at roughly, it's getting really hot, 40, 50 degrees. Let's see if it's hot to the touch, but I can hear, oh, I hear water. Is that going to scald me? Oh, it's actually not that bad. I don't know if it stops once it's done. Coffee machine, oh, we got a few things getting hot. You can see the heating element in there. 60 degrees, Jesus. Wiring's looking good. I guess that's where the hot water is coming out there. What's that? 50 degrees. Powers our fuse. Probably about 50 degrees as well. Anything else? Not really. I'm taking this bloody time. How's our timer? 2 minutes 8 seconds in. Can I probe one-handed? What is our voltage on that pin? You won't be able to see it, but it says 12.95. So a pretty constant voltage. What is this noise? What's going on here? Is that good? We're at 6 minutes. Is that bad? Do I have a torch? It's... Oh, we're full. That must mean we're done. Is it going to turn off? Oh, look at the steam. Oh, it turned itself off. We've got coffee. What's the timer? That's not a timer. About 7 minutes. How are we looking? Good. Is this hot to the touch? It's pretty damn hot. Thermal. I mean, it is reflective, so we're not going to get an accurate reading. It's probably, you know what, that's probably relatively accurate. In fact, we intentionally create a spill of hot water outside. And what's hot here? So, any spillage down there? Not really. The hot end. Oh yeah, it's pretty hot. Fuse. Yeah, we're good. Considering how late it is, we're going for a hot chockey before bed. I don't know if this is just going to spill everywhere. Now, as we reach the halfway point, I have had a thought. Because the two battery terminals were terminated together, I was wondering how it knew what voltage. It could measure it, or if it understands which thermistor is in use, it could be doing it that way as well. So, if I connect this to the positive and to the positive terminal to maybe potentially make it think it's using an 18 volt, will it make anything faster and draw more current? Alrighty, hot chocolate is brewed. Result, a bit of a watery mess, but it is hot. Is it too hot to drink? Oh, I can definitely tell it's going to be too hot to drink. It's pretty bloody hot. I mean, it worked. It doesn't really taste like a hot chocolate. It tastes like warm water. As expected. Alright, like I said before, I've connected up to the 18 volt one. Now this one from memory was to the positive, so please don't explode. Didn't explode. We're going to see if this one brews any faster. Not really a fair comparison considering this has already been preheated and done too now. So we'll hit start. Start. Alright, we're at the 5:30 mark. Sounds like we're out of water. We're just below the filter. So, again, probably preheated. So it took longer. I mean, shorter, less time. But, in theory, if not, it was quicker. I reckon it's crap though. I reckon it's just because we were already warm. Is it off? Yep. Yep. Yeah, so what I'll probably do now, look, I mean, I could wire up to the 12 volt one, but I'll probably just do it off to the 18. It doesn't seem to make a difference anyway. Best case, I get better speeds. Worst case, we wear out the heating element faster. But yeah, regardless, I'm not super fast. But I'll drill a hole in the back and put a grommet in, and I'll buy an Anderson for this. Right, before I slap it all back together, drilled a hole in the side with the grommet. It's in there tight. Shoved my connector down there. Soldered up my 10k resistor, and I'll just shove that in there. This is the other one from the 12-watt battery. I just put some heat shrink over it. Now, if you do, because they're just plug terminals, if you do have the spade bit to go on that, because this is not a standard like 6.4, it's the smaller one, you could just put a spade bit in and then put it into there. That way, this thing is like fully rebuildable to new. And then you could even run the cords outside or 3D print a plate, whatever you want. I don't care, so I've drilled holes. And then I have just heat shrink the ends of those. So now I've reassembled it, and I've just got to get an Anderson for the end.